Hi there, welcome to today's class. So today we are looking at circle theorem, that is plane geometry 2. Under plane geometry 1, we studied about the angles involving plane figures, right? Now in plane geometry 2, we are also studying plane figures, but this time they are inside the circle, and because of that, they have different properties from what we studied in plane geometry 1. But don't forget to subscribe to our channel, click on the subscription button, and then also click on the notification button. So whenever we post a video, you'll be the first person to have a view of it. And if you have any problem or anything you want to discuss with us about, you can call or WhatsApp 0549-169-506. Alright, so today we are looking at the introduction. As we do always, we introduce the topic before we start with the main thing we are supposed to do. So today we are looking at the main properties that is involved in circle theorem, and then after we'll continue with the calculations, right? Now before we start, so let's first take a circle. Now you all know that when we take a circle like this, the distance around the circle, the distance around the circle from one point, starting from one point coming to the same point, is called the circumference of the circle, right? So we call this one the circumference. That's the distance around the circle. Now any point from the center, if this is the center C, any line drawn from the center to any part of the circumference is called what? The radius. Now radius is singular, so when you have more than one radius, we call it radii, right? So a radius can also be something like this. Once it starts from the center to any part of the circumference, we say it's what? Radius, and if it's more than one, it's radii, okay? Now, whenever you draw a line from one part of the circumference to the other without passing through the center, you realize that we started from one circumference here, and then we ended at another circumference, right? But it didn't pass through the center. That particular line becomes what we call a chord, okay? That line becomes a chord, and a chord separates the circle into two. You realize that now we have this part, this chord is separating into this part, and then this whole bigger part, this whole area, right? So a chord divides the circle into what we call segments. Now because this one is the lower portion, this one becomes what we call the minor segment. And then because the rest that is here, this part is the bigger one, this one becomes what we call the major segment. Okay? Alright, and then remember I told you that when you draw a line from one part of the circumference to the other and doesn't pass through the center, is a chord. Now what if the line passes through the center? Now it's still from one part of the circumference to the other, but it passes through the center. This time it becomes what we call the diameter, right? And then you realize that from here to here is radius, but from this side to this side is radius, from this side to also this side is radius, because it's from the center to the circumference. So you realize that when you multiply radius by 2, you get what? Diameter, which means that when I have a radius and I multiply it by 2, I'm going to get what? A diameter. Or when I have a diameter and divide it by 2, I'm going to get what? The radius, okay? Alright, then we also look at this. Whenever we have two radii inclined at an angle, this is a radius, this is also a radius, right? So two radii inclined at an angle, say theta, then it also separates the circle into two parts. You realize I separate it into this part and then also this part, okay? So two radii inclined at an angle actually divides the circle into what we call sectors, okay? It divides the circle into sectors, but because this one is the bigger aspect, we call this one the major sector, and then because this one is the minor aspect, we call this one the minor sector, okay? Alright, and another thing I also want you to note here before we move on to the main lesson is how to read angles. Okay, how to read angles. That is one of the problems that students usually have. So, supposing I have an angle like this, is if I have something like A, oh, let me add another one, B and C. If I want this particular angle, say theta, how do I name this angle? This angle is, you know, students always say when you give them an angle, let's say angle AOB, and you ask them where is the angle, they will say O, right? They will say O, but O is not an angle, O is just a point. Are you okay? O is just a point. So if I want to read this particular angle theta, look, the angle started, it touched the line A, this line A. It touched the line A, came through until it came to touch the line B. But the main angle is the middle one, that is O. So if I want to read this angle theta, theta is equivalent to angle AOB. Look, angle AOB. It ended at the B line, right? You can also write this one as AOB and put the angle on the O. It's also accepted this way. Now, what if I want this particular angle, right? Let's say alpha. Look at where it started. It started from the B line, right? And then ended at the C line. So this is actually angle BOC. Okay? That's angle BOC. What if I want this whole angle? Look at where it started. It started from where? A. And then ended at where? C. So this one is actually angle AOC. Are you getting that? Alright, so having known properties about the circle and also how to read angles, we'll end on this episode, and then on the next episode we are going to look at the properties of circles, right? So until we meet next time, I will say goodbye for now.